Welcome to this course on waste management, focusing on domestic and municipal systems. In Module 1, we will lay the foundations for understanding waste, including its background, composition, sources, regulatory frameworks, and primary treatment and processing technologies such as anaerobic digestion, composting, incineration, and recycling. We will also address how human behavior and industrial activities interact with waste management. 1.1 General background, waste, MFA, and economics. Waste is a byproduct of human activity. It can be solid, liquid, or gaseous, but in this course, we concentrate on solid waste from domestic and municipal sources. Waste is not just a nuisance, it represents materials that once had value and resources that could be recovered. Material flow analysis, often abbreviated as MFA, is an important tool that helps us understand how materials move through a society, from extraction to use and eventually disposal. By mapping flows, we can identify inefficiencies and design better waste management systems. From an economic perspective, waste has both cost and opportunities. Collection, transportation, treatment, and disposal represent significant municipal expenses, while recycling and energy recovery create economic value. Sound waste management balances environmental protection with financial sustainability. 1.2 Sources, quantities, and composition of waste. Municipal solid waste, or MSW, comes from households, commercial establishments, institutions, and sometimes small-scale industries. Its composition varies depending on lifestyle, level of industrialization, and cultural practices. Typical categories include organic or biodegradable waste such as food scraps and garden trimmings, paper, cardboard, and packaging, plastics, metals, and glass, hazardous household waste such as batteries and paints, construction and demolition debris. Quantities are usually measured in kilograms per capita per day. Developed countries tend to produce more waste per person than developing nations, but the latter often face challenges of rapid population growth and limited infrastructure. 1.3 Legislation, regulation, and control. Waste management is governed by national laws, regional directives, and local regulations. Legislation sets responsibilities for municipalities, industries, and citizens, while regulation establishes standards for treatment and disposal. Control mechanisms include licensing of waste operators, standards for incinerator emissions, rules on landfill design and closure, targets for recycling rates. The aim of regulation is to safeguard human health, protect the environment, and encourage resource recovery. 1.4 Anaerobic digestion of municipal solid waste. Anaerobic digestion is a biological process in which microorganisms break down biodegradable material in the absence of oxygen. For municipal solid waste, this often applies to food waste, green waste, and sewage sludge. The process produces biogas, a renewable energy source composed mainly of methane and carbon dioxide, and digest it, which can be used as a soil conditioner. Anaerobic digestion reduces landfill volumes, mitigates greenhouse gas emissions, and contributes to renewable energy targets. 1.5 Composting. Composting is another biological treatment, but it occurs in the presence of oxygen. Organic matter such as food waste, garden clippings, and agricultural residues is decomposed into humus-like material. Composting can take place at household scale or in large industrial facilities. The end product, compost, improves soil fertility and structure. The process also reduces landfill burden and recycles nutrients back into ecosystems. 1.6 Incineration. Incineration refers to the controlled burning of waste at high temperatures. Its advantages include significant reduction of waste volume, destruction of pathogens, and potential recovery of energy in the form of heat or electricity. However, incineration is controversial due to concerns about air emissions, such as dioxins and heavy metals, and the management of ash residues. Strict emission controls and advanced flue gas treatment technologies are essential to minimize risks. 1.7 Reuse and recycling. Reuse and recycling represent key strategies in the waste hierarchy, which prioritizes prevention, reuse, recycling, energy recovery, and finally disposal. Reuse involves extending the life of products, such as refillable bottles or second-hand clothes. Recycling involves processing waste into new raw materials. For example, metals can be melted and reused, plastics can be reprocessed, and paper can be pulped. These strategies conserve natural resources, save energy, and reduce environmental impacts. 1.8 Recycling technologies. Recycling technologies vary across materials. Mechanical recycling of plastics involves shredding, washing, and remolding. Chemical recycling breaks plastics into monomers for repolymerization. Glass recycling involves crushing and melting cullet into new glass products. Metal recycling recovers valuable metals through smelting. Advanced sorting technologies, such as optical sorters and magnetic separators, have greatly improved recycling efficiency. 1.9 Waste management behavior, people. Human behavior plays a critical role in waste management success. Public participation in waste segregation, recycling programs, and responsible consumption determines outcomes. Awareness campaigns, incentives, and community engagement are necessary to encourage environmentally friendly behavior. Barriers include lack of awareness, cultural attitudes, and inadequate infrastructure. Addressing these is as important as the technical aspects of waste management. 1.10 Industrial solid waste, audits and minimization. Although our focus is municipal waste, industrial solid waste overlaps in many areas. Waste audits help industries identify sources, types, and quantities of waste. With this knowledge, they can adopt minimization strategies such as process modification, material substitution, and cleaner production technologies. Minimization reduces disposal costs, improves efficiency, and lessens environmental impacts. In this module, we introduce the foundations of waste management. We examine waste sources, composition, legislation, and control. We explored anaerobic digestion, composting, incineration, recycling, and the influence of human behavior and industrial practices. These principles form the basis for more advanced discussions, which we will cover in Module 2.